To save some time, I've already set up this question. I'll read it to you and I'll show you where all this comes from. Determine the molecular formula, right here, of a compound containing 85.7% carbon and 14.3% hydrogen by mass, and they give us the molar mass of the compound. That's from the question. Now, it's going to be following the GRASS method like we're used to. So here's my givens. Right there, 3 of them. That's my required. Now we have to kind of figure out the arrange, and the arrange isn't one formula and you substitute. It's a bunch of stuff. So let's figure this out. First thing I want to do is get from percent into something I know how to work with, which is mass. So I'm going to assume there are 100 grams of this compound. Okay? You have to say where this mass is coming from. They don't tell us how much of it we have, so we can assume any number we want. That would mean that 100 grams equals 100% of the compound in that case. Therefore, the mass of carbon is equal to 85.7% times 100 grams over 100%, which equals 85.7 grams. Same thing for hydrogen, would be 14.3% times 100 grams divided by 100% as a conversion factor equals 14.3 grams, which is better. It's better than percent, but it's not as good as moles. When in doubt, find the number of moles, which is always the mass divided by the molar mass, which is 85.7 divided by 12.01. Yours is 0107. Mine's 011. So we'll use your number. 07 grams per mole. And I gotta type that in my calculator. While I'm doing that, I'm assuming it's going to be somewhere around 7 or 8. 85.7 divided 12.0107. I get 7.13. So that's got to be right. 0.13530435. Remember, don't round until we get to the end. Moles of hydrogen equals mass divided by molar mass, which equals 14.3 divided by 1.00794. I'm assuming that's going to be around 14. And it's 14.1873524. So my ratio of carbon to hydrogen is 7.13530435 to 14.18735. I think that's a 5. I gotta write this a little cleaner. 24 divided by the lowest number. So what I'm doing now is, while that's the ratio, it doesn't look very neat. So I'm going to transfer any uncertainty over here by making one of the numbers perfect. Means that's a 1, 2, and I'm guessing that's going to be 2, a 1 to 2 ratio, but I have to actually do the math. 18735 24 divided by 7.13530435. I got 1.9883314. Oh, 18. Well, 1.988 tells me that that's a 1 to 2 ratio basically, so it's a CH2 empirical formula. But that's not what it wants. It didn't ask for just empirical formula. If it did, if it said what's the empirical formula, you're done at this point, CH2. It asks for the molecular formula. So the molar mass of my CH2, sorry, that should be 8. I'm going to erase it. CH2 empirical is equal to, well, let's find out. It's equal to carbon, 12.0107, plus 2 hydrogens, equals 14.02658 grams per mole. This one is 84, so clearly it's not CH2. So how do I know what it is? Well, the compound is going to be some multiple of this. This isn't the right way to write it, but that's what I'm thinking. It's going to be some multiple. So the multiple is the molar mass of the compound divided by the molar mass of the empirical. The lowest possible number I get doing it this way is 1. Right? If it was 14 divided by 14, it's 1. It's CH2 is the answer. It's not in this case. It's 84.0 divided by 14.02658. And that's going to be 84 divided by 14.02658. I get 5.988.6, which is about equal to 6. So that means it's C6H12 is my molecular formula.